మీరు లైవ్ అయిపోండి అంతే.
లైవ్ అయిపోయింది
అయిపోయారా?
అయిపోయింది.
అయితే నాకు కొత్తగా వస్తుంది. లైవ్
ఏ నా మాటలు వినపడట్లేదు.
నేను చూడాలి.
అదే నువ్వు పంపించు, ముందు లింక్ పంపించు.
వినిపిస్తుందా? అంటే బాగాలేదు ఇక్కడ.
ఫ్రెండ్స్ అందరూ లైవ్లోకి వచ్చే వరకు, లైవ్లో వచ్చిన తర్వాత మనం స్టార్ట్ చేద్దాం క్లాస్ని. డేట్ షీట్ ఇచ్చేసారు సిబిఎస్ఈ క్లాస్ 12th ఎగ్జామినేషన్కి వెళ్ళి. ఓ సారీ oh sorry, our friends be come online within 2-3-4 minutes. We will wait for their activation. Yes, 2 children already joined with us, few more expecting within a short period of time. Then already the date sheet of class 12th examination has given. There is only 2 days gap. Third is the English, and 4th 5th, I think these are the 2 days, and the next day is the physics. So the children has to plan according to these 2 days gap, each 1 day for 1 textbook. After the first examination, immediately after the first examination, English examination over, immediately you have to start the revision for the class 12th physics. If you come to the live, just to send a yes, yeah, hi, something you just type, so that I can able to know it is audible. Just to send a message. Yes, Anjan is already yes, clearly say hi. Yes, other children please come here, so that we can start the lesson. And the topics that you already solved for these 2 days or 3 days gap, I said 3 papers at least you have to revise. In the doubts, whatever you have the doubts, just you type, mention it, or otherwise randomly I can revise the topic wise. I think 4-5 children are there. Children are 5 to 6 joined, but none of them is typing hi. Only Anjan sent a message. May I start lesson revision of these lessons? May I start quick revision? May I start? No. Join. Yes. Hi. Ayushi joined with us. Anjan joined. Next, the others, just to say hi so that we can start. Yes, Akshita also said hi. Right, means it is audible. I think everyone is online. Good. Now we'll start revision. If you have the doubts, just to mention. Right, Hena Rani also joined with us. Good. Hena Rani is also joined with us. Akshita, Ayushi, Anjan, and other children also come into live. Okay, good thing. Okay, now I will start to teach how to prepare quickly for 2 marks, 3 marks, and 5 marks. The pattern already changed. There are a lot of choice, internal choice are given, so the scoring is so easy. This time CBSE class 12th, Ipshita also joined with us. Good. Shall I start the revision? Yes, Subham also said namaskar. Good thing. Very good joining, very good beginning. So we'll start the lesson discussion. If you have the doubts in between, you can type and send the message so that I can discuss that topic only. Yes, sure. Okay, we will start now. Yes, sure. Okay, the first lesson, very clearly I am telling the properties of charge and its properties. Next, Potential means what you call formulas are similar. Electrostatic force, electrostatic field. Aishi is saying that we have doubts. Okay, okay. Let Aishi send, because what you can, I cannot listen you because this is one way soundtrack. So can you type that one? Yeah, can you type it, those things? Can you able to send those doubts? Can you able to send those doubts? If it is difficult, we do one thing. The revision trips I will finish. After that, we will send through, discuss these doubts by sending the documents, attaching the WhatsApp group or something, because here one way only possible. Your voice cannot be able to listen by this side, only one way communication. Yes, you can send the doubts in the WhatsApp, so that I can explain. You take a photograph. Yes, sir. Can you discuss the important topics of semiconductor? Good. Okay. You just in meanwhile you put the doubts in the WhatsApp, so that I can take this. Yes. What is the difference between MF of solenoid and toroid magnetic fields of? Okay. Harshita is asking. Okay. Good. Okay, one by one. Meanwhile, you send a WhatsApp to the engine so that I can see the questions and I can discuss very quickly. Okay, for one by one. Solids and semiconductors, what you have to learn, I am telling. First one is junction formation. Before going to the junction formation, energy band gaps. Energy band gaps for semiconductors, conductors, insulators. Insulators greater than 3 electron volt, semiconductors less than 3 electron volt, and conductors the energy gap is 0. You have to clearly show these two bands, valence band and conduction band. Valence band and conduction band. Valence band, when we are talking, where the free electrons, outermost electrons, are bond sharing electrons due to doping or undoped, whatever, these lie in the outermost level, valence band. If these valence band electrons get sufficient energy, they can jump into the conduction band. So once they jump, that material is able to conduct electricity. So due to this, we are doping two types. What is the difference between? Yes, I will tell you. Harshita, please wait. First, I will finish the semiconductor topic. After that, we will go for the solenoid and toroid. Okay, quickly I will say the topics. Okay, so just I am revising so that you can quickly able to understand the things. Um, I will do one thing. 1 minute. 1 minute. I will keep on a stand off so that. One minute. I am holding. I am changing my direction so that the light will be ample to use to see. The light will be ample of light will be there. 1 minute. Otherwise, if it is not shaking at all, we will continue this one topic like this. Okay. Now, these valence band, conduction band. This is the 3 marks question to draw the figures, and you have to draw these 3 marks questions. Energy band diagrams. Second one is N-type and P-type semiconductors and their energy levels. These are given in the NCERT textbook. These diagrams, you may please practice these diagrams. Once you practice these, damn surely you get full marks of each diagram. 1 mark, 2 mark, whatever. The next one, valence band, conduction band diagram, say N and P-type semiconductors. After the junction formation, PN junction formation, once you form the PN junction diode, yeah, right. Yes. Okay. PN junction diode, fusion and what you call it, drift. These are the processes. After this process, PN junction, various types of PN junctions, light emitting diode, photodiode, and solar cell. Especially out of these junction diodes, this is more important. Which one? GNR diode. Exactly. GNR diode is very important. Their characteristic graphs, GNRs as well as the other PN junction diodes. GNR used as the voltage regulator. After this, NPN transistor. NPN transistor and characteristic curves. NPN transistor characteristic curves, input and output graphs. Next, amplifier. NPN common emitter configuration में amplification of the signal, input signal and output signal diagram. Why the phase difference is 180 degrees. Mathematical explanation, NPN transistor as an amplifier. After this, gates, logic gates, AND gate, OR gate, NOT gate, the combinations NAND, NOR, and the circuit diagrams and various waves, input waves, how these input waves given as the output waves. These you should practice. These are the 2 marks question, input signal to output signal draw by using the given gates during the different intervals of time. After this, communication, all the definitions in the communication. Next, block diagrams. Okay, block diagrams, yes. Are you following? I think okay, all are able to listen. Block diagrams के बाद you can after this block diagrams you have only one amplitude modulation. Amplitude modulation, that is small derivation. Okay, that's all. If you read properly these things, you get good score. Full wave rectifier. Next, what do you call it? Full wave rectifier के बाद someone is asking, yes sir, all are able to listen. Okay, good thing. Now full wave rectifier के बाद half wave rectifier बिल्कुल पढ़ेंगे नहीं. Full wave rectifier, GNR diode as a voltage stabilizer, NPN transistor as an amplifier, gates, and graphs, different diagrams in the NCRT. Okay, I think this ends for the lesson. And Harshita's doubt I am going to explain you. That Harshita is asking about magnetic field inside the solenoid and toroid. What is toroid? Toroid is a continuous solenoid. There is no endpoints. Solenoid, we have what you call and one end and another one, in current here and out here. Long cylindrical tube, current is flowing due to induction, whatever, there will be some back EMF. Of course, when we are calculating magnetic field, no need to discuss about the back EMF produced. But if someone asks you, okay, just I will clarify that intrinsic and extrinsic semiconductors. Okay, good doubt. So coming back to intrinsic and extrinsic doubt, see, to remember you, I said a easy method. What is that easy method? Intrinsic, internally sick, extrinsic, externally sick. So being a biology student, what you know about? Extrinsic means the parasites coming from outside and causing the disease to the body, pathogens. So this one especially, you can remember, intrinsic means pure semiconductor, extrinsic means impure semiconductor. Impurity के लिए what we are doing? We are doping 2 kinds, one pentavalent and one trivalent. Pentavalent means 5 electrons, 5 free electrons, and out of these 5, 4 will be made covalent bonds with the nearby semiconductor elements in the lattice, and 1 electron is free. So such type of extrinsic semiconductor donate 1 extra electron, which we call unpaired electrons. So this is negative type, N type. Positive type means holes are created because of shortening the 1 electron. How can we shorten 1 electron? Very simply, okay, we will come back one by one. Finishing that, we will go for the mutual induction, what do you call this? 1 minute. After this, we will go with this magnetic field due to solenoid and toroid. After we will go to the next doubt of okay. Once if we will finish this one, what we called these extrinsic means externally sick. What we will remember means by doping we are getting impurities. Impurity means trivalent to pentavalent nearby these semiconductor elements group. What we called the valency 4, 3, and what we called 5. So the positive type and negative type. Yes, we are talking about the positive type. Positive type, it has only trivalent. Because of the trivalent, 3 electrons are available. These 3 electrons shared with the nearby silicon atoms or whatever semiconductor lattice that we have. One is shortfall to one is created vacancy. So this vacancy be occupied by any electron, any 1 electron. So this we called P-type semiconductor. Now Harshita's question coming back. So solenoid and what we called 1 minute, solenoid and another one is called yes, toroid, right. The solenoid end to end, if you join end to end, I think it is making noise to you. So I am going back a little bit. I'm going back. Okay, I'm going back so that you won't get disturb of yours. Right? Yes. When we are talking about solenoid and toroid, when we are talking solenoid, the continuous means the coil continuously flows and the current is flowing, creating the magnetic field. Whereas toroid means end-to-end joining. When we are joining, it makes a loop. Means there is no entry and there is no exit exactly, but it is impossible. So these entries means leaving of current and entering the current in the coil are very near, very closer. So it makes just like a anchor structure, means locking of circular. So the magnetic field outside and inside. Here see, we can divide into three regions. What are those three regions? Exactly outside the solenoid means toroid. There is no magnetic field. The inner space of the toroid is also having any magnetic field. Only the magnetic field is produced inside the solenoid. The expression here, when they ask to prove, you have to take ampere circuit law and assume one loop which is including a point outside the region of the toroid and inside the region of the toroid, the second loop, and third loop is within the toroid, means the core where we are exactly the magnetic field is produced inside the toroid where we are keeping the core. That way we can calculate mu naught by Ni. Yes, I think it is over. If you have any doubts, please just any doubt, just depend upon this, Harshita, just you send me message. And another doubt, someone is asked, what is the doubt? I want to check the messages, what to put the another topic. Someone asked another question. Just look at me. What is that? Okay. Yes, Einstein's equation, please. Okay. So Einstein equation is very simple in dual nature. Einstein says that if an incident photon having the h nu energy striking on a metal surface, it emits what we call electrons, photoelectrons. Photoelectrons are emitted. When the photoelectrons emitted, just I gave an example once. You remember that if your relative is given 1000 rupees as a guest, he come into your home and enjoyed this yesterday's 25th celebrations or something, 1000 rupees given as your pocket money. You can utilize in the two ways. So one, you can utilize that completely spending with your friends and outside with the friends or someone, or otherwise that 1000 part of that yes 1 minute, Subham, energy band diagrams are important, of course. Energy band diagrams are very important. You have to practice. Very important, of course. Coming back, this 1000 can be divided into as you like. Suppose I want to increase my kitty bank's balance by preserving 800 rupees, only 200 rupees I can spend. That's left to you. If suppose the entire 1000 you can give a treat to your friends, that is your left to you. Similar way, the h nu energy when supplied by a photon to the atom or the electron which is on the free surface of a metallic surface, it can absorb this entire energy and may utilize in the two ways. One is to knock out this electron, means to come out from this metal surface. Some energy is utilized which we called work function. The rest is utilized as its kinetic energy. The remaining energy is as its kinetic energy. If the incident photon is exactly equivalent to 2, its stopping potential is work function, just it comes out the surface, that's all. It cannot able to leave the metal surface. It's only knockout. So the photon's energy may be equal to the work function or greater than the work function, causes the photoelectric effect. Less than the work function does not cause any photoelectric effect. Remember this. And the photoelectric equation, Einstein said this: h nu is the photon energy is equal to work function plus kinetic energy. means h nu is equal to h nu naught plus half mv square. H nu is equal to h nu naught minus, sorry, is plus half mv square. If you want to calculate the kinetic energy alone, half mv square is equal to h nu minus h nu naught. Got it? H nu minus h nu naught. So this energy difference whenever there is, then the electron, photoelectron can move with the kinetic energy. If suppose if we apply potential opposite to moving electron to stop, which exactly equal and opposite stored in the form of its stopping potential energy EV naught. So the kinetic energy is equivalent to EV naught. So EV naught is also equivalent to h nu minus h nu naught. From this only we calculated the wavelength by using the de Broglie, and the moving electron especially has this stopping potential the value, and the de Broglie दोनों mix करके हम लोग what we read, the wavelength the lambda is equal to 12 point, yes, someone explain the concepts of nuclear binding energy, fission and fusion, right? Under the conditions will a combination of thin lenses act as a plain glass sheet. Yeah. So the last doubt, what he asked, combination of lenses gives a glass slab like structure. It is possible, of course. One convex and one concave lenses whose focal lengths are equal. For example, we know the power of convex lens, for example 10 diopter. Convex lens का power क्या है 10 diopter, and concave lens का minus 10 diopter. For example, if we use such two lens combination coaxially, when we are keeping this plus 10 diopter and minus 10 diopter gives the 0 diopter, means what we call 0 means infinite. The power is 0 means focal length is infinite. Whose focal length is infinite? Yes, there is no exactly infinity curvature means parallel plates. So it is nothing but a glass slab. Means when we are joining convex and concave lenses of equal focal lengths, of course their signs are opposite. We know convex is always positive, concave lens is always negative. When we join together, their focal length is equal to 0. So net focal length formula, what is the net focal length formula? 1 by f is equal to 1 by f1 plus 1 by f2. So suppose we are talking about here 1 by focal length whatever 1 by 10 minus 1 by 10. So what happens? 1 minus 1 0. 0 by anything is 0. So 1 by f is 0. So focal length is equal to infinity. So infinity means focal length infinity means those boundaries are flat in surface. Means parallel surfaces. It is just nothing but a glass slab. Okay. Not only this case. One more case. You have the same effect when the glass convex lens is dipped in a liquid of refractive index of the same. Suppose I am having a convex lens of focal length 1.5. Yeah, suppose refractive index of the convex lens is 1.5. Yeah, yes, refractive index is 1.5. It hasn't any units. Do you remember that? I think so. Focal length को centimeters use करेंगे and power को diopter use करेंगे units. But whereas refractive index haven't any units. Why? Because it is a ratio. It is simply the ratio. So because it hasn't any ratio and the refractive index of a given lens is 1.5, if we immerse in a liquid whose refractive index is equivalent to the refractive index of the glass, yeah, in such cases it is disappeared. Yes, we cannot identify because there is no refraction, there is no reflection. When we dip into the solution, the convex lens is immersed. When we immerse, there is no refractive index. You cannot identify because it behaves like a single medium. So single medium, the ray won't bend, ray won't reflect. So in such cases, it is very difficult to identify the lens boundaries. So here also, it just like disappears. The convex lens disappears or concave lens disappears, their focal lengths are equal. I think one more doubt someone asked, I couldn't explain. Second doubt someone is asked this convex lenses, and any more doubts? Just you type and send a message. I think some more doubt you asked. I think I look into back. Sir, under what condition will a combination of what is the relation between dielectric constant being introduced and potential energy? Okay. So dielectric constant, when we are talking, if your children like, just you press the like symbol, just to click it because 0 likes. So to encourage our first experiment of online based teaching, just to click like button. Yeah, like button, just to click it. Ah, yeah, one what we are talking about, dielectric constant. Here see, dielectric constants, when we are talking about, the definition is so simple. It is the ratio of permeabilities. Yes, exactly. Permeabilities of a medium with respect to of permeability of free space. Permeability of a medium to the permeability of free space. Similarly, when we the same in terms of forces, in terms of electric field, in terms of capacitance. So in so many ways we can express. How can we express potential energy? So how can we compare the potentials? Yes. How can we compare with the potentials in terms of dielectric constant? Dielectric constant symbolically we represent K, and relative permeability epsilon R, content by introducing potential energy. Yes. Oh, okay. You don't want how it affects. You want, okay, okay. How it affects the dielectric constant. Just I'm coming to that point. Just to listen. When we are talking about potential formula, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, Q by, am I right? Q1 Q2 होगा potential energy, Q होगा potential के लिए Q by S R, exact 1 by 4 pi epsilon Q by R. This is a question based on the capacitor, parallel plate capacitor. When we are keeping the dielectric slab, how it will affect its potential energy and charge. This is the question. I got it. Now just to listen. If the cell is connected with the capacitor and we introduce a dielectric medium of K in between the plates, the source potential is constant. Keep in remember, when the capacitor is connected with the source, ray coverage at a point. 1 minute, Aniket, I will come to your question. Just I will finish it. Then you resend the message. I will tell you, clarify the doubts. But first, we will finish this one. What is that? V is equal to 1 by 4 pi epsilon naught Q by R. Okay. It is when the free space we are talking about. So whenever we are connected this parallel plate capacitor with the external source, it is not disconnected. When it is not disconnected, there is no change in the potential. Potential में change नहीं होगा क्योंकि the source potential is constant. If you discharge the cell, means what you call disconnect the cell, and you introduce the dielectric slab, the capacitance increases. When the capacitance increases, as the definition given, the potentials in terms of the dielectric constant K, the relative permeability and the dielectric constant K is equal to V by V naught. So V is equal to KV naught. The potential increases by K times of initial potential. When the dielectric slab being introduced, the potential increases K times. The potential energy, why? Because simple formula I am telling. K is equal to V by V naught. V is nothing but 1 by, excuse me. V naught by V, sorry for this. V naught by V. So V is equal to 1 by K V naught, V is equal to 1 by K V naught. The dielectric constant, whatever the value of K, it reduces the potential in the free space 1 by K times. Okay, someone asked another question. That question we will see. Will the reflected ray coverage at a point when a parallel beam of length is incident on a concave mirror of large aperture? Okay. If there is no absorptional energy, 100% the light rays are reflected back by using any kind of plane mirrors. Again, it goes back infinity distance. If we are having the concave mirror, all these meet at its focal. All the rays are meets at its focus. Now, yeah, the properties. According to the properties, after the reflection, the rays seems to be meet at the focal point of the concave mirror, same side. Yes, one more doubt. Someone is typing. What is that doubt? Someone asked another question, I think. Yes, please explain half-life, mean life. Okay, so I'm coming back. Beam of light is incident on concave mirror. Yes, concave mirror over. Now, half-life and mean life. This exactly when we are talking about the half-life, the radioactive half of its initial. The time taken to reduce to half is known as half-life. Mean life means to complete the given sample, whatever we have, suppose 100 radioactive atoms are given in a sample, this 100 to disintegrate, how long it takes time, the total time, and the number of atoms means mean we are calculating. Means the mean life half life. So keep in mind, because suppose 100 atoms to become 50 atoms, it takes half life, and the 50 to becomes again the half life, and 25 to become half, and 25 to again a half, 12.5 again goes up, means it is a simple calculation. So the mean life is sum of all the half lives and number of half lives, you can say. So that is the reason the formula when we are talking about T half is equal to 0.693 by lambda, and T mean is equal to 1 by lambda, where the lambda is called. Yeah, so do shape and size of a capacitor affect its capacitance? Yeah, definitely. Definitely. Definitely the shape affects the capacitor, because there are different types of capacitor: parallel plate capacitor, cylindrical capacitor, spherical capacitor. Because the formula of parallel plate capacitor, if you see, C is equal to epsilon A by D. A is the size of the plate. If you change the shape, if you change the size of the plate of the capacitor, definitely it affects. Definitely, no doubt in it. It depends upon the dimensions of the capacitor. Yeah, one more doubt. Someone is asking that mean life, half life over. Next, one more question. Someone put up. Could you remember? Please repeat the question. What someone asked? Yeah, sir. We will have doubts in chapter nuclear, right? I am taking the nuclear chapter. See, what is important for the nuclear? I am telling only those parts you have to remember. Nuclei first radius r is equal to r naught to the power 1 by 3, and nuclear density. Density is independent of the mass number. It is one of the important question. And isotopes, isobars, isomers, what do you call this? Just simple remember the definitions. Very rarely they ask you the questions, of course. Next, coming to the point of nucleus, mass defect. So mass defect is nothing but it is the difference between sum of the mass of all protons and neutrons present in the nucleus, and differ with what rest nucleus means the actual nucleus has the less than the original mass it should contain. What is the original mass it should contain? It is the total mass of, what is the total mass of protons and neutrons present in the nucleus, but it is always smaller than that sum of these. That difference in this mass is called mass defect. Where it is going, this mass defect, according to Einstein, this is converted into the energy form, which we call binding energy. So mass energy conversion E is equal to m del c square, del m c square, because del m is the mass defect, c square is the velocity of light whole square. So this is converted into the binding energy. This always expressed in electron volts, not in the joules. Keep in mind. So 1 AMU or 1 U is equal to 931.5. Generally the conversion factor 1 U is equal to 931.5 million electron volts, MeV, because generally you should remember एनर्जी लेवल्स मीन्स न्यूक्लियस का बाहर इलेक्ट्रॉन वोल्ट्स है, न्यूक्लियस के अंदर मिलियन इलेक्ट्रॉन वोल्ट्स है. दिस इज द डिफरेंस. Whenever we are talking the energy levels of electron, in the case of atom, the chapter, the units are electron volts. If you are talking about the nuclear energy levels, they are MeVs. Keep in mind, this is a small difference. Atoms electron volts में represent करेंगे फर्स्ट लेसन में, नेक्स्ट लेसन में न्यूक्लियस जो है बिलियन इलेक्ट्रॉन वोल्ट्स में. The energy levels of the nucleus, even the gamma emission, the nuclear, what you call the beta emission, the energy is all mentioned in MeVs, not joules, MeVs. Okay, coming back, the binding energy when you are getting, if you divide with the mass number, it is gives us binding energy per nucleon, EBN. To get stability, the EBN must be larger. What is binding energy per nucleon? It is the energy required to make separate of all the nucleons without they have the interaction, means you are taking away each nucleon to infinity separation. There won't any interaction between them. So that is known as binding energy per nucleon. And binding energy per nucleon and mass number graph is there below what we called yes 30 and 170 in between. These are stable nucleus because they are above 8 million electron volts. Yes. How does the intensity of scattered light vary with the wavelength of incident light? Okay, sir, do electrons and tend to, okay. Just after finishing this, I will coming back to this doubt. Mm, what we are talking about, children, the first thing, okay, okay, live में guys बोलना है ना, children नहीं बोलना. See guys, what we learn now, yes, yes, very good response. What we are talking about, I think one way, are you following? I think slowly I am telling, explaining, repeating the sentences so that you can able to understand. Where we struck the energy binding, okay, EBN graph, binding energy per nucleon curve below 30. These are called lighter nuclei. These binding energies are so small, even if you see 1H1, 1H2, 1H3, 2He4 is little high. The rather we comparing the hydrogen atoms are very small. So these nucleus are fusing together to gain more and more binding energy. Yes, my binding energy per nucleon to get stability. So the hydrogens are reaching to helium, and such heliums are reaching to some nitrogen. So which are peaks in the graph. Similarly, the other side, other part of that one, what is the other part of that one? Above 170. These heavier nucleus have the binding energy per nucleon below the 80 million electron volts. So these are to get stability, they are dividing to 2 or more. Generally 2 nuclei, they are split into 2 nuclei so that their binding energy per nucleon is increased, so that they goes beyond this 8 MeV, so that they get stability in the both the processes to acquiring the binding energy per nucleon to increase, they release a certain amount of energy. So they definitely have the high binding energy per nucleon. I think understood this one. So now the doubt what the children asked, the another doubt, the messages I would like to know. Intensity graph. Yes, intensity versus scattering of light. So the intensity versus scattering of light, when we are talking I is equal to I naught cos square theta by 2. This is based on the Malus law. No. I is equal to I naught cos square theta by 2 is Malus.
Intensity vary with wavelength of incident light.
Oh, sorry. Okay, this after doubt, dual nature coming back. This graph just this graph we will first discuss. What is that graph? Malus law. Suppose light is falling due to scattering, intensity how changes. It is nothing but sinusoidal graph, but there is no negative part above the x-axis because it is a cosine curve. It is a cosine curve. Oh, no problem. Next, what is the question? Intensity?
Intensity varies with wavelength of light.
Intensity varies with the wavelength of light. Okay. In which case, beta? Intensity varies with the wavelength of light.
Does the intensity of scattered light vary with wavelength of incident light?
Okay. So intensity here, one thing, amplitude. It depends upon the amplitude. Intensity purely depends upon the amplitude. I am not getting the question. I will send you back the answer by or the message, sending a message. Wavelength. Okay. Any more questions that you have? That you have?
Do electrons tend to flow from a region of lower potential to higher potential?
2 electrons
Tend to flow from a region of lower potential to higher potential.
children, electrons always move what you called low to high, whereas positive charge, which you call positive charge, move high to low. So when positive charge is moving from high potential to low potential, opposite to that electron should move. Matlab, it is in the case of conduction of a conductor. If it is not so, if only we are talking about the static charges, if you are talking about the static charge, that is also true. The electrons move from what you call low to high because it is opposite to the positive charge motion. So low to high it moves. Yeah, any more doubts? Okay. I think the work's over. You finished. May I stop live stream and come back to interaction session with Sir, do electrons turn over? It is necessary that the point charge has to be positive? No. By convention, in electrostatics, we are considering positive charge means point charge, because coulombs are way for the static charges, especially point charges case. So that is the reason all these formulas that we are learning in the chapter 1 is based on positive point charges. Test charge means point positive charge. It is a convention by default. By default. But even we can talk about the electrons motion. We can talk about the positive charge proton motion. So proton is not the point charge, for your kind information. Test charge means 1 coulomb charge we are talking about. 1 coulomb consisting of so many. Are you getting my point? Point charge means not a single point, a single proton, or single electron. Point charge means group of collection of charges, but it is not occupying more space. Point charge to be positive. Yes, okay. Sai Siddharth also clarified his doubts. Next, any more doubts? Yeah, may I sign off and we will discuss over phone. If you say if you want to continue this, I will let continue, or otherwise I will come out from the live session and a interact session over the phone we will do. Okay. All the best, children. Bye. See you.